Afternoon everyone. So you see equation of motion we will start today. What is equation of motion? Equation of motion is the equation written using motion variables. What are the motion variables? S means distance or displacement, U means initial velocity, V final velocity, A acceleration, T is time. So there exist four equations of motion in class 11. First is velocity time relation, velocity after time t second, which is given as v equal to u plus 80, and another is st relation or displacement after time t second, and s equal to ut plus half 80 square. Third equation is velocity displacement relation, velocity after distance covered s, v square equal to u square plus 2s. The last one, the new one, is distance covered in nth second. Nth second, how much distance covered? We will start deriving these equations both in graphically and analytical method. Okay, so analytically we will derive how. You see there, first you see an object starting its motion from A with initial velocity u meter per second and time 0 second, and after covering S its speed increases to v meter per second after time t second. Then we want to relate these motion variables in the various forms of equations. So let us start deriving first equation of motion. So let us start first equation. First equation, we can go through the definition of instantaneous acceleration, A equal to dv by dt. So dv equal to a dt. Now here we have to know about integration. What is integration? The opposite of derivative. Integration symbol, this is integration of x to the power n dx equal to x to the power n plus 1 by n plus 1. In derivative, what will happen? In derivative, the power will be multiplied and it will be subtracted by 1. But here, what happens? The power is divided with increasing plus 1, and in the power also it increases by 1. Okay. Then example, let us example how it will carry out. X to the power 2 dx. Integration of x to the power 2 dx. Dx means it is small part of x. Okay. Integration of x square x to the power 2 dx. You cannot multiply x square with x from this d. Dx is one thing. Remember, dx is one thing, a small part of something. So x to the power 2 dx is x to the power 2 plus 1. Similar way, x to the power 2 plus 1 by 2 plus 1, x to the power 3 by 3. Similarly, take another example, integration of dx. Integration of dx, what will happen? Here we have to convert it into the form of x to the power n. So x to the power n means x to the power 0 dx. So x to the power 0 plus 1 by 0 plus 1, that is integration of dx equal to x. Clear? Now you say, if integration of dx is x, dx means what? Dx means a small thing, very little thing, little variation in x, and x means total variation in x. From dx we can find x by integrating it. Similarly, here you see what is there? It is there dv. So what we have to find? In first equation we have to find v. So what we have to do? Just consider this case. Integration of dx is x. Similarly, integration of dv will be v. So we have to write here integrating above equation with proper limits. Okay, we'll get. So let us go. So after writing symbols, we have written integration of dv and integration of a dt. A taken out because it is integration over t, time. Dt means integration over time. Variation in time is there. So a will consider as constant. So it is taken outside of the integration symbol. So a integration of dt. Now we say this is integration of our velocity. How velocity is changing? Limits with proper limit. Limit means how it is changing. You see here velocity was u and here velocity is v. So velocity changes from u to v. So you have to write here u, lower limit, and upper limit you have to write v. Here you have to write u, here you have to write v. That is integration of v from u to v. Velocity changes from u to v, initial to final. Then here time changes from, you see there time is first time is 0, then final time is t second. Okay, now integration, you know integration of dv is v. So v, as integration of x, integration of dx is x. Similarly, integration of dv will be v. Okay, then it will taken from u to v. Then a integration of dt will be similarly t from 0 to t. Now removing this bracket, these limits will be placed here. in that variable value, first upper limit, then minus lower limit. Then what you will write? V minus u equal to V minus u equal to a into t minus 0. So what will be V minus u equal to a into t? Simply that V equal to u plus at. Okay. So this is your first equation. So this is analytical derivative of analytically deriving first equation of motion. Simply what integration part is there, only integration of dv is v, u to v. So v place re prathame first you have to put upper limit minus lower limit. So here it is done, v minus u equal to a, similarly t minus 0, upper limit minus lower limit. Okay. So now let us move to second equation. Second equation is s equal to ut plus half at square. So we have to take the definition of instantaneous velocity, v equal to ds by dt. So now ds equal to v dt. So v you know from first equation, see here from first equation, v equal to u plus at. So u plus at into dt. So ds equal to u dt plus at dt. Now you say, in the previous case we have found out v from dv by integrating. Similarly here we will find s from ds. We have to find s na, distance, by integrating above equation with proper limit. So writing integrating both sides of the above equation with proper limit, we get integration ds. You say here integration over t is there, it is time integration, so u will be taken outside. Similarly here time integration t into dt, so a will be taken outside. You look here, a is taken outside and t dt is there, means t to the power 1 dt, here t to the power 0 dt. Now we have to write the limits. What are the right limits? Limits for s, you see here s is here 0, here distance covered is s. So 0 to s, then time 0 second, here t second. So only two variables are there, displacement and time. So here you have to write 0 to s, here you have to write 0 to t. Okay. So I have written the limits here, 0 to s, 0 to t, 0 to t. Then solving this, integration of ds is s, integration of dt is t, integration of t to the power 1, here you see t to the power 1. So integration x to the power n formula you have written x to the power n plus 1 by n plus 1. Similarly t to the power 1 plus 1, 2 by 1 plus 1, t square by 2, 0 to t. Then upper limit minus lower limit s minus 0, u upper limit minus lower limit t minus 0, a by 2, 2 taken outside, t square minus 0. Okay. So now it is clear, s equal to ut plus half at square. So we'll move to third equation. Now you see a peculiar thing will happen here. From the definition of acceleration, a equal to dv by dt, but here we have to eliminate time. How will eliminate? Multiplying ds and dividing ds, because ds by dt will produce velocity and time eliminated. So ds by dt is v and dv by ds. So a equal to v into dv by ds. Now you see cross multiplication, a ds equal to v dv. Now we will do integration. Okay, integrating both sides of our equation with proper limit. So let us go. Now integrating both sides of our equation with proper limit, we get integration a, integration over s is there, so a is taken out, constant, and limit is 0 to s, already discussed, and v dv, integration over v is there, therefore v is inside the integration. Okay, then velocity changes from u to v, so u to v written, then a ds 0 to s, and v to the power 1, you know the formula, v to the power 1 plus 1 by 1 plus 1, so v square by 2. Integration formula is x to the power n plus 1 by n plus 1. Here v to the power 1 is there, v to the power 1, so v to the power 1 plus 1 by 1 plus 1. U to v limit, then a upper limit minus lower limit equal to half upper limit minus lower limit, v plus v square u square. Then as equal to v square minus u square by 2, 2as equal to v square minus u square. Okay, here 2 left, v square minus u square by 2, here left by 2, then v square minus u square equal to 2s. Okay, so this is about all the three equations, and the fourth equation will be little bit different from this, so we'll discuss later. Thank you.